Hello and welcome to another Teck Campus Coffee live webinar. This is an opportunity for you to learn about career paths at Teck directly from professionals in your field.
We'll be speaking to technical representatives from a variety of fields at Teck, and they'll share why they enjoy what they do.
Participants also have a chance to directly ask speakers and recruiters questions and get a good understanding of why Teck is a great place to work, as well as where your strengths, talents, and learning opportunities lie.
I've recently moved to Elkview operations, so that's the most southern mine in the Elk Valley in our BU. And there I work within the maintenance department, and I kind of have three pillars of my team that I'm responsible for. So I always describe the engineering team and my position as the provider of technical services. So we've got GSs or general supervisors that supervise, electricians and mechanics working on the equipment in the field and in the shop. And then my team provides the technical services. So I have three different main work areas. So I've got a senior engineer who takes care of our maintenance and reliability team. I've got a senior engineer that takes care of our asset health and condition monitoring team. And I have a senior planner who takes care of the planning and scheduling. So I'm going to go into a bit more detail about the maintenance and reliability and condition monitoring team. But for those of you who don't know, so all the work that happens on the equipment goes through a planning and scheduling process. So you want to determine what work needs to happen at the right time. You want to have the right parts there. So that's what the planning function provides. So within the senior engineering team for maintenance engineering and condition monitoring, there's three main areas. So there's maintenance engineering, and Edgardo, the next speaker, is going to walk us through, it looked like a platform job when I looked at the presentation there. So he's going to walk through kind of that traditional form of maintenance engineering. So that includes, you might be designing something in SolidWorks that the shop's going to use. You might be redesigning something that keeps failing on a haul truck. The reliability side is essentially making the equipment run when you want it to run. So, on your car, you take your car in for an oil change. That is what we call preventative maintenance. So there's nothing indicating that oil change needs to happen, but at 5,000 or 8,000 hours or whatever you change your oil on your car at, it's a time-based change out that, our manual says we need to do. What we are trying to transition to more on the equipment is condition monitoring. So this is actually one of my passions, and it's one of the parts that I love about the job the most. So I'm going to go a little bit deeper into condition monitoring, and I've got some show and tell items. So you can think of condition monitoring like going to the doctor, right? So at the doctor, you might get your blood work taken. Somebody goes and analyzes your blood work, and they might say, you have this disease, or you have this, what's wrong with you, or you need to supplement with these vitamins. The doctor might listen to your heart rate, and they might say, oh, your heart rate's too fast or too slow, and this is what you need to do to, fix that. So kind of the analogy on that side is we might go with a vibration monitor, and you might monitor, the bearing on your alternator on the haul truck, and you might find out that bearing has failed. So it's kind of analogous to how, we do preventative maintenance or condition-based maintenance on our bodies. So I have a couple items here. So and I should mention, so our main production equipment, which is what we do condition monitoring on, so we've got 930E haul trucks. We have 41 of them at Elkview. We've got 8 4100 electric shovels, and we've got 5 electric drills. So just for magnitude for you guys, a 930E haul truck to replace is about $8 million nowadays. A 4100 shovel is about $40 million, and drills run upwards of $10 million. So it's big equipment that's very expensive. So hopefully you guys can all see this. Try to get the green screen picking it up. So this is a main bearing from a QSK 60. So these are the engines that are in our 930E haul trucks. So 930E haul truck engines, we're running them at about 3,000 horsepower right now. So just to give you, kind of the size, so your main crankshaft on your engine with these bearings around it are this big. So the engines are about brand new. They're about $800,000, and so probably more than a whole bunch of our houses combined. One of these engines costs. So you can see here that there's a little bit of copper showing. So the reason that we ended up changing out these bearings were because we saw copper in the oil sample. So that's kind of like looking at your blood to see, what might be wrong with your body. So we saw copper in the oil sample, and we brought the haul truck in and we changed out these bearings. Had we not looked at the oil and had we not changed out these bearings, we could have had a catastrophic failure on the engine. So you actually, your bearing would seize up and you actually poke holes. We call it putting a hole through the block. So catastrophic failure and can cost a lot more money to replace than if we were just doing a planned component exchange. Next item I have here is a mag plug. So this came from a wheel motor, and this is all like fuzzy. My fingers are gonna get dirty here, but this is all like fuzzy iron that's starting to break off the gear set in this wheel motor. So a technician went out to the field, pulled the mag plug as he's supposed to do for an inspection, saw this. So now we're planning and scheduling this wheel motor exchange versus letting it fail. So this changes the cost $250,000 to rebuild the wheel motor. So this one would cost us $250,000. If we were to actually catastrophically fail that and not react to that really ugly looking mag plug, it would cost us upwards of $1 million to lose the core on that. So just thought I'd share a couple of the my favorite parts of the job. It's really satisfying when you see, an oil analysis result, you see this mag plug and you actually react and make a decision on, how to rectify that or change out a component before you have a catastrophic failure. So you really have a large opportunity to impact a lot of money, as I described, for the cost of these components. Last area that we get involved in, and some co-op jobs get fairly heavy in this and some don't, just depending on the group that you're working in and the projects that are happening, are project management. So just to recap, first of all, I love working at Teck and I love the area that we work in. It's one of the reasons that drew me here, and now the work keeps me here and the area keeps me here. So we have 3 main areas in engineering that you could focus on: reliability engineering, maintenance engineering, and project management. And some of our main assets are haul trucks, shovels, and drills.
Nice. Yeah, just keep in mind, students, just let you know for our trivia at the end, a lot of the content's coming from what our speakers are saying too. So just
hence
keep that
my
in mind.
recap, if you want to.
That's awesome.
So Lindsay, are you at home and just had those parts just laying around the house?
No, I had to borrow them from some engineers' offices.
I'll just tease it. I have a couple questions, if that's all right to start us off, or do you want to wait till the end, Misaki? What do you think?
Well, it's up to you. We've got a question already in the chat that I can see here. This is from George. He's a 5th-year mechanical engineering student, U of A. Hang on. Okay, so first question. How much is invested in the condition monitoring equipment at Teck?
Sorry, I'm just going to read through this question. How much is invested in the condition monitoring equipment at Teck? So we don't have a lot of capital investment for the condition monitoring. We spend millions of dollars on oil analysis every year. We don't do that in-house. We send that up to a lab in Edmonton. We do have people that are, their job. We've got a condition monitoring or an NDT technician. I obviously mentioned I have an entire senior engineer whose stream is focused on condition monitoring, but it's a little bit different. The equipment comes with a lot of condition monitoring it for mobile equipment. So again, Edgardo's got a really cool slide that shows some data that's pulled off of a haul truck. So you've got sensors all over that haul truck, and it's actually wirelessly transmitted back to a maintenance dispatch area where it's analyzed. So I can't speak to how much we invest, but it's definitely, if we didn't have condition monitoring, we'd be investing a lot more on unplanned maintenance and failures.
Yeah, he's got a second part to his question about the collaborations with universities to apply these technologies, or is it mainly internal research?
We have collaborated with universities in the past. I can't think of any major projects that we have on the go right now. There's been work, and definitely on the data science side in the last couple of years, where we're trying to make a decision based on a whole bunch of data, and we have leveraged different universities to compute that data. So yeah, when opportunities come up, we do, we are open to that. I can't think of any that's happening right now.
Yeah, to build on that, so right now we have a couple capstone research projects that are going on. Some conversations are going to happen later this week. So with electric vehicle infrastructure, sensors at the face, and alternative materials handling are some of the research collaborations that were currently started this September. Oh, and there's a third question. Is the condition monitoring used mainly logic bases or statistical models too?
So we have yet to, we had a couple of classical machine learning AI models on a couple failure modes on engines, I think high pressure fuel pumps and front corners. We weren't, we took a step back and decided that there was a lot of work that we could be doing in a more logic-based alarm management. So it costs a lot of money to do a machine learning model, and you need a ton of use cases for those failures to teach your model of what that looks like. But what we have found is you've got people that are looking at data, and they might, they're really experienced mechanics, say, that are in our dispatch, and they might see that a failure curve is happening. So what we do have is a program called Seek. So Seek kind of codifies what your eyes see. So Seek can actually say, so when we talk to the mechanic and they're like, oh, when the curve, starts to get a little bit more wide, that's when I know that that steering pump's failing. So Seek actually can aim to create, so I think the one we have right now is it looks at the area underneath the curve, and when that area underneath the curve gets to a certain number, it triggers that steering pump's failing. So not quite machine learning, but more what we just call advanced analytics or advanced alarms. Great questions, thank you.
Yeah, I think there was one more question from I think someone wants to turn their mic on. Anas?
Yeah, I just have a quick question regarding the predictive maintenance and how it's implemented. I understand a lot of companies have programs such as SAP, and it can be a hassle to change the work orders. So how are you able to kind of implement the changes that you need in like a efficient manner?
So we don't like our work order system, so we don't use SAP, but our equivalent of SAP, we won't enter a work order in, say, for a wheel motor change until there's something telling us that wheel motor needs to be changed. So we start saying some sort of condition parameter or something that we're seeing in the oil that then we say, yep, we need to get this wheel motor changed. So, and then we enter the work order and the work gets executed. If you're talking more precision maintenance, so say you've got a bearing that's getting slightly hot on a shovel, the work order would then be to go check the alignment and complete an alignment. And then that's precision maintenance. So you don't have to change out that component. You've fixed the issue. You may have shortened the life, but then that work order says that. Does that answer your question?
So there's no preventative maintenance in terms of like reoccurring work orders that happen?
Oh no, there's definitely, yeah. There's preventative maintenance and preventative inspections. But if we've gone through the maintenance strategy and deemed that, sorry, I'm gonna move my screen so I'm looking at you guys, not my other screen. If we've identified that the maintenance strategy can be condition-based, we won't go with PCR. So we won't change it out on hours unless there's something dictating that hour-based is more efficient. So we have lots of things that are condition-based or that are PCR-based. But as an example, we used to change our wheel motors out at 25,000 hours. And then when we implemented a condition monitoring program, we now change them out at 46,000 hours. So, we've got 20,000 hours, which is over 3 years extra runtime on those wheel motors, which has saved a ton of money. So we try to go condition-based wherever we can. So because it can catch early failures and it can do life extension.
Right, so just another thing, is there any like regulation-based preventative maintenance?
Yeah, so a lot of our anything that's regulated. So our kind of jurisdiction is the Mines Act. So if there's anything like, we have to do a crane inspection on a certain amount of time or NDT, anything that's regulatory based, we have to do brake checks. We got to do brake testing every single year. So yeah, we still do make sure that we're adhering to all those policies.
Perfect. Thanks a lot.
Yeah, thanks.
Great questions, everyone. Thanks for that. Okay, Lindsey, and we'll save some time at the end again to go into a little bit more detail. And in the efforts of making sure we stay on time, we'll move it over to Edgardo Martinez. So Edgardo is a maintenance EIT at our Greenhills operations, and he's got his civil and mechanical engineering degree from the, oh, you're testing me now, the Universidad de Santiago de Chile. Thanks, you're very generous. So I'll bring it over to you, Edgardo.
Sure, yeah. So hello, everyone. Good morning. I'm Edgardo. So yeah, I'm a mechanical engineer from the Universidad de Santiago de Chile. So, well, I've been working with Teck for 7.5 years now. I've been really lucky having the option to move between different business units and different sites in Chile and now here in Canada. So yeah, I'm part of the reliability and maintenance engineering team at Greenhills for the last 2.5 years. And I take care of all the asset management section here. So we basically define what our best maintenance strategy could be. So we really want to run the equipment as much as possible in a really safe and cost-effective manner. So that basically means we want to do the right work at the right time, and we want to make sure we perform the right maintenance tasks, considering the entire life cycle of the assets. So as Lindsey was saying, we decide pretty much how often we should replace components, how often we should inspect them, how often we should send mechanics to check them and perform tasks in order to maximize the value we get out of the asset. So yeah, that's super dynamic. That changes based on the challenges we can see in the quality of the parts, in practices and people working in the shop. So it's really dynamic, and we have to make sure we check our metrics and results in a weekly basis, and we adjust our strategies based on what we can see. We also need to learn from our mistakes and make sure we can improve and get better every day. So continuous improvements are an important part of our work in a daily basis too. And another of the things we pay attention to is the real-time monitoring tools. So yeah, as Masaki and Stacy were saying earlier, before Race 21 is happening, we have a lot of sensors in our production equipment. And today, through Wi-Fi, we get pretty close to real time, less than 1 minute delayed information from our operation equipment. So you guys can see in the screen, we monitor, for example, here in the picture, all the exhaust gas temperatures for the engines. So same engine, 16 cylinders, 3,000 horsepower. We want to make sure everything's working properly. So yeah, we pay really close attention to this. If we see one cylinder getting too hot, we might let the mechanics know and take some actions, take the truck down for an inspection. And if we can replace an injector, that's way, way cheaper than replacing the entire engine, as you guys can imagine. So yeah, we pay really close attention to some of the values. We have people looking the screens and understanding and in constant communication with operations and mechanics 24/7. So yeah, well, working with Teck, I feel I've been really lucky. So in my first 5 years working in Chile in the copper mines, I had the option to move between 2 different sites, really far away to each other, and also being part of the corporate office in the capital city in Chile. And then 2.5 years ago, I had the opportunity to move to Canada, also related to work. So yeah, I feel really lucky having the option of living here. I came here for work, and I found this beautiful valley, which I didn't know too much about it. But you guys can see Teck has 4 active mines in the valley around those towns. You can see Furnace, Barwood, Elford. And yeah, I've seen here also you have the option sometimes to move across the different sites, which I think is really cool. You can see different realities, different challenges. You can meet different people, be part of different teams, and I really enjoy and value that working with Teck. I also it's first time I've been part of a team with people from different countries, and I really like that. Different skills and different experiences, different backgrounds, and yeah, I really enjoy being part of the team I'm part of right now. It's like a first time I had that opportunity, and at the same time, I really, really like haul trucks. I think the mining equipment is so big and so powerful, and we move so many tons of rocks and coal every day. So every single minute counts, and I really enjoy the challenge of trying to keep them running as much as possible, and without spending necessarily crazy amount of money. I really enjoy that. And yeah, well, because not everything is work, I'm just in love with the lifestyle in this valley. When I came to Canada, I pretty much brought my bicycle, backpack, like a suitcase full of dreams. I didn't know too much about the valley, and then I just found this amazing network of trails right out of your house. You can just ride everywhere. Some really beautiful hikes, just driving 15 minutes, and all year round, right? So you have fun, winter, summer. Now just learning how to ski. That's a new challenge for the days off. But yeah, I think the valley offers so many options. It's a super, super cool place to live. So yeah, when working with co-op students, we try to, well, it depends on the projects we have by that time, but we try to work with them in, well, the entire process from design and then fabrication and then hopefully even install and see in the field how the projects we are working on work at the end. So yeah, we really like to gather some feedback from operations, from the mechanics, how things can get better, work some design, some like SolidWorks, some calculations, go into the field, get familiar with the equipment. As you guys can see in the picture, that's the latest co-op we had just finished like a month ago. And yeah, then we can see how these solutions work and if we are fixing problems, and then get feedback and get better and expand to the rest of the fleet. You guys can see in the picture like a simple lock mechanism for a ladder, which was just falling down with vibration every shift and causing the shovel to be down because of fault code in the computer. So yeah, together we designed a super simple mechanism. We even got some inspiration for a design in Elkview. So we got some help from the team lead system. So yeah, we just implemented that. Right now we are seeing if it's working properly, and then the goal is going to be just to expand to the other shovels if it's working as we want to. And also, so we have now so much data, so many sensors sending data real time. We get like terabytes of data every hour. So we are in this learning process of understanding what data can tell us. So yeah, pretty much looking some numbers, making sure we can understand better right before the failure, which kind of information we can see, and from there learn and apply that in the future. So it's it's a challenge. Yeah, I think it's just by these years we are seeing all these data. So it's like a continuous learning process for us. So I think next slide. Yeah, so right here we have like again like really close to real-time data for one of our shovels. So you guys can see this is just voltage for one of our shovels, but we'd like to see here hopefully a straight white line around 630 volts. When we have all those little blue squares is not great, because that means the voltage is just going everywhere and crazy. So yeah, we're understanding this data and working with the co-op students and some computer skills just to make sure we can get max value out of them.
Great, thanks, Edgardo. Let's see if we have any questions coming in. I'm looking in the chat. Don't see a load of questions coming in, but questions for both Lindsey and or Edgardo.
If not, I got all kinds of questions to pepper you guys with.
Yeah, fire away, Stacy.
Well, I love hearing about, obviously I do the co-op hiring, so I love hearing about what kind of stuff that students are doing. So thanks for sharing a bit about that. Either one of you can answer this, but I guess in your eyes, what would make a successful co-op? Like what sort of things does a successful co-op do in your team to add value?
I like to see when a co-op comes on site, so understanding that it's daunting and it might be a do work area. I'm always impressed when one of the first things that a new employee or a co-op, that they want to get out and they want to meet the people and they want to get on the floor and they want to understand what the technicians' pain points are. Because really, like I said, we're the deliverer of technical services for the team, but we want to make the equipment run better and we want to make the mechanics and the electricians' jobs easier. So you know, that's I'm always super impressed, like I said, when someone comes out and they don't want to get onto the computer and start looking at the data. They want to get out and, you know, take a ride through the pit and go talk to haul truck drivers.
Yeah, I think I agree. Like yeah. when they can be part of the team super quick and really get into what's going on and trying to get the hands in a project and lead the project. And yeah, I agree. Like being part of the team quick, I think it's a really successful way to start the co-op term for us as well.
And I know it might vary at times, but what would you, like I get this question a lot from students, how much do you think field versus office time? Like, are you about, what would be the percentage, I guess?
I don't know, Edgardo, do you got a hunch?
Yeah, well, I think our goal is try to aim at least 50%. But yeah, I don't know, like, well, last time we had a different times and challenges with, you know, like COVID and working from home. It was a bit different, but like currently we are working 1 week from home, 1 week at site. We try to maximize the time in the field and in the shop in the week we are working at site. So yeah, I'd say our aim is 50%. currently might be a bit less.
Yeah.
Hey, Stacey, you want to try something interesting? You want to put Chase on the spotlight? I think he's on the
Yeah.
call here. So he's just a very recent co-op student who might be able to verify sort of the man of the field, and talk a bit about his experience very briefly.
Yeah. It just finished in August there, Chase. If you're there still, Chase.
Good morning, everyone. Thanks for calling me in on the spot here a little bit. Yeah, I would agree with Eduardo. I think that a lot of my experience was sort of 50-50 in the field and in the office, kind of depending on what the overall goals and initiatives were, as well as COVID. You know, obviously there was an impact that had to do with that. But I'm a fourth year mechanical engineering student at the University of Victoria, and I've had the opportunity of completing 2 co-ops with Teck now at their Fording River operations. The first one was last year. I did a 4-month co-op in their mobile maintenance department. And this year, I had so much fun. I went back this year and I did an 8-month co-op in their processing maintenance department. So I've had kind of the opportunity to see a little bit of both sides of the coal business unit, the extraction and bringing it down to the plant, and then the processing and sending it onto the trains to the customer. And I think that one of the, kind of my favorite parts about Teck is just the vast, diverse range of experiences that I got to have there. And I mean that in the sense of I got to wear lots of different hats, and I got to assist and support in lots of cool different engineering disciplines and on different areas. So for example, in the mobile maintenance department, as a co-op student there, I was responsible for supporting the fleet engineers. So I got to work in projects related to shovels and drills and haul trucks and dozers and excavators and all sorts of auxiliary equipment like graders and scrapers. Really cool, diverse range of experience. And what started off as taking on individual tasks and assignments, creating some drawings, doing some kind of preliminary designs, with the little initiative really developed into taking on some full-on projects and responsibilities. For example, developing, as Lindsey was talking about, developing preventive and predictive maintenance strategies, performing root cause analysis on critical equipment component failures, reporting on key performance indicators for some equipment, and then launching investigations against bad actors, equipment that are experiencing frequent failure events. And then over on the processing maintenance side of things, again, this diverse range of experience. I got to support the reliability engineer, the maintenance engineer, the process engineer, and do some really cool things there with, as Lindsey was referring to, the condition monitoring program through vibration analysis, lubrication, ultrasonic testing, to really kind of predict when critical equipment failure is going to occur. And then if we're having frequent failure events, how can we redesign and trial a new component to potentially fix this issue, or try to minimize those failure events so we can maximize kind of our optimization on those equipment. Some of the other things that I got to do, for example, with the process engineer, was design fluid flow systems. We wanted to implement another piece onto our separation system, separating coal from waste rock. I'd be able to design some of that flow system and spec pumps and look pumps up out of catalogs and find which ones. And it was really exciting to see not only in the field and talk to the plumber, talk to the pipe fitters, talk to the millwrights, and talk to the trade sides of things, and then actually do the technical calculations and the flow calculations, and kind of seeing those two kind of co-align was really an incredible experience for me. Some of the other things you get to do, as Edgardo was mentioning, was do a little bit of the in-field work, So one of the things that we do in processing once a year is we have a summer shutdown. So we'll shut the processing plant down for 2 weeks, and we'll do some in-depth equipment inspections where you get to put on your fall arrest and put on your gas monitoring equipment and get into some of these really cool confined spaces within the machines and really get to tinker and view how these machines are being worn down on and what kind of stresses they're being implemented to. And I just don't have enough to say about how positive my experience is with Teck. So I'll sum this up quickly with some of my really key favorite parts were, first of all, the huge emphasis for safety that I saw here at Teck. So it can be sort of intimidating as an engineering student trying to get into these big machines, this really big company. It can be really intimidating, but they have such an amazing emphasis for safety, training, making sure that you're prepared and you know what kind of an area you're going in, and you have the expertise you need and the guidance you need to be able to do those equipment inspections safety. And the support, the team, both times I went there, really, I felt like they welcomed me in with open arms, welcomed me into the family. Anytime, I felt like I kind of hit a wall on a project and I needed some help, needed some guidance, they were there. They had the resources. They would help guide you. It was really a phenomenal experience. And Teck has some other benefits for the co-op students as well. They'll pay for your flight there and back to be able to go and do your co-op. They give you a $500 relocation assistance. They'll pay $700 towards your co-op fees for that semester. They have competitive wages. They also have a student ambassador program that you can potentially get into if you show some initiative and you had a positive experience and you'd really like to share that with other students and get them on board. And also, when you do a co-op with Teck, you really have an excellent opportunity to receive a full-time job offer coming out of school as well. And I know, especially for me, during COVID times, you can get a little nervous on making sure that you have employment coming out of school, or making sure that you're with a strong company and your co-op isn't going to be canceled before you get there, which I know that's happened to a lot of students here over this whole COVID thing. So that's just a little bit about my positive experience here, and I really would encourage you all to apply, especially with the outdoor activities you have there. I mean, you're in the mountains, you have lakes, you have rivers, you have streams. There's a ski hill in Elkford. There's an amazing ski hill in Fernie. There's biking and hiking and fishing and camping. So if you're into that kind of stuff, this really checked all the boxes for me, and I'll certainly be applying with Teck in the future to come back for a third time for sure.
And
Awesome, Chase.
For the record, if mechanical engineering doesn't work out for you, you should probably look at recruitment.
Yeah.
You covered all my stuff. Thanks for that, Chase. That's awesome. So this is just some quotes here from some former co-op students. So sort of reinforcing, I guess, what Chase has talked about as a co-op student here, and talking about the type of work they get to do. We do a survey with every outgoing student as they leave, just to let them know, like, hey, like, is there anything that you would do differently? What did you like about your co-op? What didn't you like about your co-op? And so we take some of those quotes and just to give you some insight, because I guess I could talk about it until I'm blue in the face, but when it comes from students, it certainly resonates a lot more with other students. So just give you a little snapshot here. Our co-op program, we're currently recruiting for January 2021 right now. So we've just started interviews, but our postings are actually still up on the Teck website. And so you can check the website, and I think Rachel's already put the link there on the chat if you can see the chat. It's teck.com/careers, and you can see our mechanical postings as well as the other disciplines if there's anybody outside of the maintenance side of things on the call today. In terms of benefits, yeah, like Chase had mentioned, we offer relocation support. We offer you a great competitive benefits and salary, as well as a $500 sort of settling in, more or less just to help with any incidentals for your travel here. And then we pay for co-op fees while you're with us as well, up to $700 a term. In addition to the super cool experience that obviously Lindsey and Edgardo and Chase had all talked about. Yeah, so that's pretty much the program. I do want to leave some time for questions. So there's a question about if there's a new grad program as well. And so, yeah, I didn't really get into that so much, but we do have, it's kind of a twofold question answer, I guess. We do have a new grad program, but it's not like we hire twice a year and we say, okay, we're going to hire X number of mechanical engineers or EITs. We sort of do it as needed basis. So what I would suggest if you're looking for a new grad position is just, you can set yourself up for alerts on our careers website and just keep an eye out for maintenance engineers as they come up. And then you'll see either it's looking for a maintenance EIT or reliability engineer, and you can apply that way. But that's your best bet, because they do come on as needed basis. So it's not like we have it scheduled that one time a year or 2 times a year we do it. In addition to that, we also have, there's possibilities to do a rotation, obviously, once you get in. So you may start at Elkview operations for a year or 2, and then you might shift into another area of maintenance. And obviously, we'll make sure that we get you ready to get your PEng after a few years of working with us.
So I guess, Edgardo, we didn't get around to finishing the second half of the previous question. So maybe we'll start there, and then we'll continue on the other questions.
Well, yeah, I think the experience from repair and maintenance and going from there to reliability, I think it's a really positive path. I think I even might say like it's the desired path because you understand better both worlds, execution and reliability. I'd say also reliability requires some experience with, like not just math, but also all the logic behind how we make decisions. And yeah, it's something with time, it's gonna happen. But I think the path from execution to reliability is just the ideal. I'd say the ideal path for sure.
Great, thanks, Edgardo. Now I saw in the attendees that hand is up. Is Kyra's hand up? Is it just me, or I know I've had technical issues?
I see it as well.
Yeah.
All right,
Yeah,
Kyra,
my name's
fire away.
Kyra. Hi. I was just wondering about I guess basically if you guys hire new graduates for a technologist program, or if you mostly look for, like full-on bachelor's graduates, because like I'm going to Northern Alberta Institute of Technology right now, and I am just looking to see if I could either apply for like your company after I graduate this summer, or if you guys strongly recommend just finishing a bachelor's and then doing that.
Great question, Kyra. It depends on, I guess, where your interests are as well, but we do hire technicians as well. But yeah, I think if I were going to look at a numbers game, you're going to see a lot more positions from the engineering standpoint. If you're looking for something long term, then yeah, certainly, if you're going to roll into the degree program anyway, then there's opportunities to work as a summer student as well. So that's something that you could do in between. If you're going to automatically roll right into the engineering program, we have a summer student program that we post usually around January, and you'll see postings. I know for the coal business unit. Again, we scaled it back last year given the COVID situation, and so I'm not really sure what to anticipate this summer, but we usually have a fairly robust summer student program that you can certainly look into as a sort of a bridging point into that in between the two programs.
Excellent. Okay, thank you so much.
Yeah, no
Yeah,
worries.
in 2019 we hired almost 80 plus summer students across the business. Awesome. I'm not sure if I'm going in order here, but I see a question in the chats. See here, second year mechanical engineering student wondering about when recruitment would usually start for summer 2021. Stacy.
Sure. Yeah. So we'll start recruiting for summer. So we usually do it 4 months in advance. So you're looking at January, we'll see our postings come up for the May start. And generally, most of our co-op positions are 8 months to 12 months in duration. And then, like we have the summer student program, we may have some technical positions for 4 months. But yeah, you'll see summer student positions and the summer co-op starts, the co-op in January on the website, and then posted at your universities as well.
All right, great. I see one hand up, and once again, I've had technical issues in the past. Man Ray, is your hand up? And if so, feel free to unmute and ask away.
Hello, can you guys hear me?
Yes.
Okay, I just kind of wanted to ask about the co-op summer program, and will that be available for first year students as well, or second year continuing?
It's certainly available for first year. We generally lean to a little bit more senior, like second to third year for our co-op program. Part of it is, the length of term that you're available for, but then also it's a pretty big leap as you probably gathered from the chats today. And so having a couple more courses under your belt certainly helps your success in a co-op term. So you can certainly apply. We can definitely look at it, but in an exceptional circumstance, we might hire first year, but usually second, third year that we hire for our co-op positions.
Oh, okay. Thank you so much.
Yeah, no worries.
All right. Do we have any other questions here? And just, I don't know if we talked about too much, but obviously we've gone over, and we're happy to stick around for a few more minutes to answer questions. I see there's 20 some odd people on this webinar still, so we'll probably shut it down at 10:15. So yeah, if you want to squeeze in a last minute question for anybody, feel free. Chase has got a question.
Hey guys, one question for you. You mentioned earlier in the presentation about research collaboration capstone projects.
Yeah.
What would do you think you'd recommend as a process to trying to talk to Teck and get a hold of one of those projects or propose a project to Teck that they might be interested in?
I can take this one, Stacy. So when is your capstone course start and end?
It starts in January next year and it finishes at the end of April.
Oh, okay, so it's a 4 month.
Yeah.
I'll look into it. Like, so we're in the infancy of our capstone program. I sort of mentioned in the chat here, my goal is for it to be quite large, and across, and definitely UVic is one of the schools that I had in mind. So we started. A lot of it's about communicating to the business and the value of getting involved with capstone projects. And so we had one last year, and we've got 4 this year. So, you know, and some really exciting ones. So the goal is to make sure that we can provide enough support for students so that they feel they're getting value, and then they can achieve and you know, have a nice deliverable that's achievable and challenging. So we had focused on 8 months, and we haven't really focused too much on the 4 months. That being said, between now and January, there could be some projects that come up. So I guess the main thing I would suggest you do is, since you have contacts at Teck, you could reach out to them. I've been encouraging all engineers to get involved, but now that we've got a few sort of on the radar of you know, overall at Teck, that there's the potential to for them to learn more about them, be more familiar with capstone project. But it is still relatively new for our organization overall, so a lot of people aren't familiar. So it takes a bit of sort of education as well. And so anyway, so for you in your lucky position, I would sort of just connect with some of your, you know, your previous colleagues and see if that's possible. And you know, obviously the fact that you've got experience and at site, you could leverage that to be ahead, you know, to be ahead of the game in terms of, you know, starting on a particular project, right?
Thank you.
Yeah. Good question. All right. Any other? Oh, hang on. Okay, there's a couple thank yous have come in. All right, that's great. Well, I appreciate it's great that you know, every time we get the thank yous, that's wonderful. I think I see a couple responses in the feedback survey. So once again, I really encourage you to fill out that feedback survey. It's going to be invaluable for us. I've got 4 so far, but we had about 50 on the call, so yeah, a few more would be great. All right, some more positive feedback. Well, the feedback is great, and actually positive and constructive feedback in the survey would be great, because one, we want to be able to see what we're doing right and continue to do that. But the constructive feedback, obviously we continue to experience some Microsoft technical challenges. We're trying to work around that. We may switch the platform in the future, but yeah, all of your feedback is welcome.
Another question that I often get, Edgardo, so if there's no questions coming through, I'll speak to it a little bit, and maybe you can give me some color for it. A lot of students ask about things that they can do to prepare for a co-op term. So any programs that they should be aware of. Like, I know that I believe Lindsey or yourself had mentioned SolidWorks from the design standpoint. Are there any other programs that student could get exposure to sort of prepare themselves for a co-op with Teck?
Yeah, well, I think one of the skills we really appreciate nowadays are, you know, like, well, computer skills all across the picture. Like, for sure, well, some Microsoft Excel, Word, PowerPoint, and at the same time, so some programming skills. I think that's really valuable now, because we have, again, like so much data every day, and in order to maximize also our time analyzing information, when we have co-ops with programming skills, that really fits really well in our team and makes things easier for everyone else too.
Yeah, awesome, thanks.
Yeah, I agree with you. And talking to some of the professors from different from in my past, and talking to a lot of our engineers, you know, I've been encouraging a lot of students to really look at you know, learning Python on their own, and getting comfortable with data. The future is data. And so the more comfortable you are in that side of things, on top of it, if you can bridge between, say, mechanical engineering and data science, and be comfortable in that area. We've got a lot of experts in mechanical engineering, as you see, but what we want to be doing is partnering them with people who are comfortable on the data side, and so together they'll be very valuable to the organization. So I see a hand up. Maybe we'll field one last question potentially. Man Ray.
Yeah, and so you mentioned about learning Python on your own, right?
Yes.
And I kind of want to ask, because right now in our my electrical engineering class, we're learning about Java as opposed to Python. So would that still be similar, or would you still recommend learning Python?
Great question. I'm not the most technical person, but from what I have talked to the technical people, so yeah, I'm not gonna. Yeah, I'll be the first to admit I'm not the most technical. Now, from the people I've spoken with, there are different types of software you can use, and Java can be as well. The main thing is getting comfortable with the data and being able to do some programming and to work with the data. So Python, it was just one that's very universal. And the feature-wise is going to be beneficial as well, but there's others as well. So if you learn Java, great. But yeah, just a matter of applying that and be cognizant of what companies are using.
All right, thank you again.
Yeah, great question. All right. Well, should we? Looks like we are. We're down to just a dozen or so people still on the call, so or at least students on the call. Well, should we wrap it up, Stacy?
Yeah, I don't see any other questions come up,
Okay.
but we appreciate you joining, everybody, and sticking around for a little extra chat. That's great.
Yeah.